everybody, today we are gonna be um simulating evolution technically. So this is very simple, by the way. So evolution is much more complex, but I'll be explaining in the most simple way. So let's say we have a bunch of squares, okay? These squares are really bad at living. So see how they always just die? So one after a few more tries, one might have a low diff chance, but for some reason this has very high ones. So we're waiting. Anyway, so they can replicate. Their color tells you how good they are at replicating. So if they're like green, they're really good. If they're purple, just like purple like this, they're really bad. And the bulge, as you can, there's a few more squares that have a little bit of bulge effect, and those are the ones with a much higher diff rate, so those are trash basically. And we also have the equilibrium zone. What this does, it's like the maximum clone that can exist. So if I set this to 100, there can only be 100 more or less of 100 clones. If more, as you can see, and the pop variable, which stands for population, it doesn't. It either gets fixed out at 100 or 90, or less. So now if I just lower it, as you can see, the population goes down with it. And now if I raise it up to 100, it's now back at 100. As you can see, the color is changing. It's purple, green, red, all of these colors. And this is basically how good they are at reproducing. Now they don't have a lot of space in the equilibrium zone, so they can't reproduce. But when one of them die, they have a more space to spawn. And I can go higher, and there's more population now. And I can make lower it down to 115, and as you can see, it's following the equilibrium zone, so it can't go over it. Actually it can, but it can't get like much higher than it. It's like the zone where it just stops. So the code looks like this. So I'm gonna pause this. So we have, this is the code here. So what it does is the setup. We're gonna set population to 0 because we don't want misleading population. Then we have a equilibrium zone set to 100. You know what that is. The original DR is original diff rate, so I've set it at 25. So usually they have a diff rate of 25, and we set the diff rate to original DR. Original RR is replication rate, but original, which the original ones are the for this for all sprites, but the one without original are the ones that are for this sprite only. And then we just do this, that just clones, and as you can see, it clones. And here we have when we start as a clone. So we're gonna change population by 1, change diff rate by -5 to 5, and if diff rate is less than 1, we set diff rate to 1. And we're gonna do the same thing for replication rate, and it just sets the color here, so it's not very important. And here's the forever loop. Also, there's another forever loop here that just makes the cubes move. So anyway, forever, if pick random diff rate to 100 is 100, we change the population by -1 and delete the clone because it died. And if pick random replication rate to 100 is equal to 100, population, if population is less than equilibrium zone plus pick random -5 to 5, we create a clone. So technically what it does, it says if it's less than equilibrium zone, it can have a baby. Otherwise it doesn't. And that's literally all of the code that's running this. It's kind the results are very simple, but this is like the most simple type of evolution you can make in Scratch, of course. You can clearly make better versions since I've been building way better versions like evolution with apples, for example, but that will be showcased in a later video. I hope you enjoyed. Don't forget to subscribe and like to all of the videos. Thanks for if you did that.